Welcome back, students. In this section, we'll try to understand the concept of normal distribution. Now, this is a very important concept to understand in statistics and research methods. And whether you are the graduate students, research students, or you are appearing for any kind of competitive exam, understanding this normal distribution is very important. Now, as I said before, at the time of explaining the concept of measurement of central tendency, we saw the data generally that is distributed like this, right? So we have seen that. Now, normal distribution is a continuous distribution. It is not a discrete distribution, okay? And we try to understand the data, how it is located near the central line. Now, this is generally the shape of a normal distributed curve, okay? And this is applicable only for the continuous distribution. Now, this may be the symmetric. Basically, this is the symmetric across the central line. What does this mean? It means nothing but if this is this normal distribution curve, then this side and this side, this is symmetric, okay? The area under this curve, this side, and area under the curve right hand side, both are same. So like you consider that the human being, okay, human face, human body, so we are symmetric from the axis, from the central line, right? So similarly, this kind of data or the normal distribution is also symmetric across the central line. And when the moment I am talking about the central line, it is nothing but it may be mean, median, mode, you know that, okay? And for normal tendency, mean equals to median equals to mode. Clear? Now it looks like a bell curve or something. So see, if you see like this, we have seen lot of bell, okay, in temples and all. So this looks like a bell shape, nothing else, okay? This is the nothing but a property of a normal distribution. Now this graph is characteristic by standard deviation and the mean. Now standard deviation and mean, this is most important to understand. Now this line, central line, is nothing but we are representing by mean. We generally do not represent by median or the mode. For normal distribution, we represent by mean, and then how far the data is located with respect to the standard deviation. Clear? Now, unlike discrete distribution, so let's say binomial distribution or the Poisson distribution and all, when we saw this, okay, this is the uniform distribution, binomial distribution, like this. Unlike that, this normal distribution, okay, we calculate the area under the curve. So that means the area under the curve, whatever the area is there under the curve, like this in this normal distribution, we will say this is equal to 1. And for discrete distribution, we say the summation, okay, the bars, okay, the value of the bar summations of the probabilities are equals to 1. In this case, we will say the normal distribution, the area under the curve is equals to 1. Hope you have understood, right? So unlike discrete distribution, where sum of all bars, okay, sum of all bars equals to 1, in normal distribution we'll say the area under the curve is equal to 1. Asymmetric curves display the skew and are not normal. What does this mean? Asymmetric curve means which is not symmetrical. So this is asymmetric curve, this is mean, and this is left hand side and this is right hand side, both are not symmetrical, correct? It may be like this also. Clear? So this kind of curves is not a normal distribution curve, we call it as a skewed curve, skewness, okay, which we have discussed already. The probability of a specific outcome is 0 in this case, and we can only find possibilities over a specific interval or a range of the outcomes. Now in this case, one thing we need to remember, that this curve is an asymptotic curve. Now the moment I am saying asymptotic curve, that means it will not touch the x-axis. It will never touch the x-axis. If you can, this is the x-axis and this is the y-axis. So this normal distribution curve is nothing but asymptotic. Asymptotic curve. It means it will never touch the x-axis, whether it is a right hand side or whether it is in the left hand side. Okay. Now this is the main concept on that, and we can only find the probabilities over a specified interval or the range of the outcomes. That means, as you know, this is the area under the curve it represents. Then let's take an example. We try to understand whether what is the probability of this point being here under this curve. Okay, so accordingly we make the calculations. So this is the concept of normal distribution. Now one important thing which I would like to explain you, that when we are drawing this asymptotic curve, as I said, that it will never touch the x-axis any point of time, right? So this is the main property of the normal distribution curve, and whenever you are drawing that, please be careful that you also should not touch. Now in this case, this portion we call it as a tail of the curve. So this is the lower tail of the curve, lower tail of the curve, and this is called the upper tail of the curve. Okay, hope you have understood. Now in the next section we'll try to understand few different diagrammatic representation of normal distributed curve and how it is related to the mean and how it is related to the standard deviation. So in this case we'll talk about the important conceptual cases of normal distribution. Now let me draw a figure out here. Okay, so this side, let's say it's a probability. Okay, this side is the probability, and this side I am mentioning nothing but the values. Okay, and here let's say this is the mean. Let's say this is 10, this is 20, this is 30, this is 40, this is 50, and data is distributed like this, and let's say like this. Possible? All are normally distributed curve to some extent. Okay, all are normal distributed curve, and this is the mean. Let's say x bar equals to 30 out here. Hope. Now as per this figure, I am just noting it down. This is A, denoting by A, this is B, and this curve is C. Okay, so there are three curves. It is mentioned in a same axis, and what the conclusion I can do. So from this, if I try to tell you what will be the the relationship in between the mean values of this curve, and this curve, and what will be the relationship in between the standard deviation of curve A, curve B, and curve C, what will be your response? Now let me do these things. So in this case, all XA bar equals to XB bar equals to XC bar, because all the curves are normally distributed and the average is 30. So in this case 30 is average for C curve, B curve, and A curve all. So this is satisfied. Not satisfied, this is the condition whatever we can conclude, right? And the second one related to the standard deviation, this is nothing but standard deviation of A curve, standard deviation of B curve, and standard deviation of the C curve. This is the condition it will follow. Why? Because think that curve C is widely distributed, curve B is little bit less distributed, and curve A is least distributed. So if I see the data points are lying in between this for curve A, but for curve B data points are lying in between this and this, correct? And for curve C it may be possible data points are lying in between this range. So in that case what happens, if more and more you are getting the range and the data distributed like this standard deviation also is higher, right? So generally standard deviation is nothing but we try to understand how it is deviated from the central line standard wise, right? So this is more deviated. So in that case I can say standard deviation of C curve is higher than standard deviation of B curve, and which is higher than the standard deviation of A curve. Hope you have understood. Now let's consider another type of diagram. So let's say in this diagram it is given like this. Okay, so there are three different normally distributed curve A, B and C. This side is the probability and this side is the nothing but the data average or the data points, right? So it may be 10, maybe 20 and so on and so forth, right? So in this case we can easily say their mean points are different. For curve A, mean points, let's say 15 example. For curve B, it may be 30. For curve C, it may be 40. So I can easily say, or you can conclude that mean value of A curve, mean value of B curve and mean value of C curve, the condition, or I will say we can conclude from this graph that this is like this, right? Because this is, let's say 40, this is 30 and this is 15. So x A bar lesser than x B bar and lesser than x C bar. Now what else we can conclude from this diagram related to the standard deviation? Okay, but if you see this related to the standard deviation, it is like this. So in both the cases, what I say, this dispersion, spreading of the data is same. Clear? Spreading of the data is same, right? So in that case I can say, if I draw like this, the spreading of the data like this, okay, if I say like this, then standard deviation of A is nothing but equal to standard deviation of B equals to standard deviation of C. Any doubt? Because the distribution or the shape of all this normal distributed curve is same. Only the difference is in that the peak is same, the distribution is same, standard deviation is same, only the changes is in the average value, right? The mean value. So in this case mean value is this one, this point. In B curve mean value is this point, and for C curve the mean value of this point. So hope you have understood. Let's consider the figure 3. So this is figure 1, figure 2, and let me consider the figure 3. So in that case, let me draw a figure like this, and you can tell me what could be the relationship in between the average values and the standard deviation values of curve A, curve B and curve C. So let's say the curve is drawn like this, then let's say this is this, and let's say this is this, correct? So these are all nothing but the normally distributed curve. It may be little bit skewed this side, but consider this a normal distribution curve because I am drawing hands free. Okay, so this is a curve A, this is curve B and this is curve C. So if I draw the mean values, it is easily, you can say that mean values, that means x A bar, x B bar and x C bar is different. So x A bar is less than x B bar is less than x C bar. Why? Because this point is, let's say 10, this is 20, this is 30 from the origin. Clear? So this side is the probability and this side is the values, sample values, correct? Now we need to understand in the case of standard deviation. Now in this case you can say the data, if I say that 100 data is there, okay, and distributed like this. In B figure also, in B normally distributed curve also 100 points are there, but this is distributed like this, and same 100 points are there in the C curve also, but this is distributed like this. So in short I can say the distribution is it is lesser than the distribution of this one and then the distribution of this one, correct? So I'm just drawing in this sense bar wise. So you can say that this bar is sling, this is medium and this is a fatty bar. So that means the distribution of the data is much more larger here, lesser here and the least here. So in this sense, if I can compare with this data, okay, you can easily say with this data and the figure, you can easily say that standard deviation of A less than standard deviation of B, and less than standard deviation of C. Correct? Because this is the mostly distributed. Think that there are 100 students are there in a class. Okay, this class is widely spread, big class. Okay, though it may be possible the peak is less, we are not considering about the peak. We are more concerned about here for the mean, which we know that different, and the spread. Okay, so it's a big class. So you will see that 100 students are sitting widely. If it is a little bit smaller class, 100 students will be sitting close to them. And if the class is more small, okay, smallest one, then you will see the 100 students, same number of students are sitting very close to close, right? Close to each of them, right? So in that case, we can say that the standard deviation of A is lesser than standard deviation of B and lesser than standard deviation C. Now these are the three main interpretation of three types of curve. Okay, normally distributed curve, which is curve A, curve B and curve C, putting together, and what kind of solution can happen. So herein I have explained that if I tell you the curves are, if I say you the mean is same but standard deviation is different, then this curve that represents this curve. If I say that standard deviation is same but mean are different, then it represents this curve. But if I say the standard deviation and the mean all are different, then it represents this curve. These are all three types of combinations of the problems or the possibilities which are there in the statistics related to the normal distribution, and the relationship between all these curves average and the standard deviation has represented here. Hope you have understood. In the next section, we will try to understand the concept of about the empirical value of normal distribution or the standard normal distribution. Now, when I am talking about the standard normal distribution or the empirical value of normal distribution, I will explain in detail what is the standard normal distribution in the next slide or the next lecture. Okay, now all the time I am saying you standard deviation, standard deviation, standard deviation. That means what? How it is deviated from the mean. But it may be possible, as I said in the previous lecture, you have seen that mean is also different, right? Correct? Mean is also different. For one curve mean is 10, for another curve mean is 20, for other curve mean is 30. So in that case, what happens? Okay, understanding the concept of normal distribution or calculation becomes little bit complicated, and that is the reason we consider that, okay, look, now in this case I am going to standardize the normal distribution. What is that? I am standardizing, saying that mean will be 0. Mean value will be 0 of the curve, normal distributed curve, and how far the data point is, I will measure that how far they are situated in terms of comparing to standard deviation. That means here we will be considering as a standard deviation as a unit. Okay, I will again explain you in the upcoming lectures, but you remember this much of thing, and so that I can explain you the empirical value of normal distribution here. So as I said that in this case, what I am just going to understand that all the data, they are falling under this normal distributed curve. Okay, as I said you. Now initially for normal distributed curve, normal distribution, I said this is the mean value. Correct? No doubt in that. And this mean, it could be 0, it could be 10, 15, 20 and so on and so forth, because origin we are taking here, right? Starting from 0, this is 10, 20, 30, 40, 50, 60, 70 and all, right? And accordingly the data points were segregated. It may be here, it may be here, it may be here, it may be here, and it may be here. Any doubt in this? Correct? There is no problem in that, right? It can be possible. In this case, what I'm trying to say that it was very difficult. Now what I'm saying, look, I do not know, I do not want to change the mean. For any curve, I will say mean is 0. Then you tell me how the data will be segregated or data will be distributed. That is the main concept. So in this case, as I said, I will say mean equals to 0. So I'm writing 0 here. So in short, origin here, I'm saying the normally distributed curve, okay, the central tendency line is nothing but 0. That means mean equals to 0. Clear? Now if you have understood this, now I will try to understand how much standard or how much far is this data points, okay, from this with respect to the standard deviation. Now what I am saying, now I am considering standard deviation as a unit. Let's take a very simple example for the explanation purpose. Okay, think that I am saying that look, you need to reach to the airport. So you will say, okay, fine, I will reach to the airport. I am asking you how long you will take it. You will say 75 minutes. Okay, somebody I am saying, another person, your friend is staying maybe some far away from your place, and I am asking him how long you will take to reach the airport. He will say, let's say 90 minutes. Now for my understanding, 60 minutes and 90 minutes, it is little bit confusing. I am saying I don't understand in minutes. You just tell me, okay, how long it will take to reach the airport with respect to when you are converting this into hour, HOUR, right? So what you will do then, 75 minutes I said, first student will take time to reach airport. 75 divided by, let's say, 60, that is the hour. 7 by 6 hours. Clear? Similarly, second student said that he will take 90 minutes to reach the airport. So 90 divided by 60 hour, right? So that means 9 by 6 hours. So it is a standard that I am saying that you are representing the data in a hour format. So 1 hour, 2 hour, 1.5 hour, 2.5 hour, and so on and so forth, right? Here in what I am doing, instead of hour, think that I am telling you how far this data is distributed with respect to the standard deviation. 1 standard deviation, 2 standard deviation, 3 standard deviation, and all, right? So in this case, what I say, it is right hand side will say plus and left hand side will say minus, because this is 0. So in this case, I will say this is plus sigma, this is plus 2 sigma, and this is plus 3 sigma. Clear? That means 1 standard deviation plus 2 standard deviation and 3 standard deviation. In this case, I am saying this is minus sigma, minus 2 sigma, and minus 3 sigma. Hope you have understood what I want to mean. So that means now I am going to represent the data in between minus 3 sigma to plus 3 sigma. Clear? Now you can ask me a question that, sir, how come it is possible? Okay. Is there any guarantee that all the data points will lie in between minus 3 sigma to plus 3 sigma? Now lot of research has happened. And as per that, we have seen that in between minus 1 sigma to plus 1 sigma, minus 1 sigma to plus 1 sigma, in between this 68.8%, 68% all your data points will lie. In between minus 2 sigma to plus 2 sigma, almost 95.5% will follow. Okay, 95.5% will follow, and remaining, if in between minus 3 sigma to plus 3 sigma, okay, almost 99.9% data will fall. Now what does this mean? It means irrespective of your data, if we are converting the normal distribution curve into a standard normal distribution curve, then I can say, look, 99.9% of data is falling under minus 3 sigma to plus 3 sigma. Isn't it good? It's very good for us to understand and for the calculation. And this is the concept of empirical value of normal distribution, and it is called also the standard normal distribution, because I am standardizing the normal distribution curve to the standard normal distribution, and this is also called as Z distribution. This is also called as Z distribution, wherein I said mean equals to 0, nothing but x bar, right? Here, this one. So mean equals to 0, and always I have taken standard deviation is nothing but the value is 1. It may be plus 1, it may be minus 1. Now this is must to remember in case of standard normal distribution. In case of normal distribution, this mu value will be different and there is no existence of the standard deviation, right? But for normal distribution, the existence of this is mu equals to 0, and in this case standard deviation equals to 1. Hope you have understood.